Okay. Hi, I'm going to be making this review video on 7.6 double integrals over rectangular regions. So we have 4 objectives to master, which is recognizing when a function of 2 variables is integrable over a rectangular region, recognize and use the properties of double integrals, and evaluate double integrals over a rectangular region, and using double integrals to calculate the area of a region, volume under a surface, or the average value. I'm just going to be focusing mainly on doing double integrals and how to do it and how to get through it. So here is our main concept. Here is a little integral review. A helpful tip when I have 2 functions is to split up the integral, kind of separating them. So I have the integral of 6xy squared plus 3x squared dx. That means that we are focusing on dx, and any y values is a constant. So first we are splitting it up, so we have the integral of 6xy squared dx plus the integral of 3x squared dx. This just makes it a little bit easier to manage and to work with. Another thing to do is to bring out the constants. So since this is dx and y is a constant, we can bring out the 6y squared. So we have 6y squared, the integral of x dx, plus 3, and then the integral of x squared. Then from there, we can just integrate it with the power rule, as we would typically do, and then simplify it to this. So let's look at the same thing, but on this other side. Notice how on the left side we had dx, so y is the constant, but here we have dy instead, which means x is our constant. So that is something to be careful about and to pay attention to. All right, so the first thing I'm going to be doing is to separate them like we did over here. So the integral of 6xy squared plus the, can't forget the dy, plus the integral of 3x squared dy. And then I'm going to take out my constants, which in this case x is our constant. So 6x integral y squared dy plus 3x squared. And I know we are taking out this whole thing, but we still have an integral of 1. It's not just 0 or nothing. So I'm going to put a 1 there just to help me visualize it. 1 dy. And then from there, we would just integrate as usual. So 6x, and I'm going to be using the power rule. So y over 3, or y cubed over 3, plus 3x squared times y. The integration of 1 is just y. And then plus c of x. And then from there we simplify it to 2xy to the third plus 3x squared y plus c of x. So that's a little concept, a little integration review. And then some helpful hints into solving integrals and double integrals. Just a little recap. Splitting splitting up the integrals. And then also to bring out the constants. Bringing out the constants is a little easier to manage in my opinion, and it's less to work with. And then from there, then you would integrate. And then lastly, simplify it. Now, when you have double integrals, they look something like this, and then you would have a number down here, and then your function. Something that makes it a little easier for me is to put values into brackets and to like separate them so you really know what you are working with. So I like to put mine into brackets, so like A and B, and then C and D. And then I just really want to make sure that I know which variable I'm going to be doing. So whether it's is dy, starting with dy, or starting with dx. I just want to make that very, very clear. So let's look at an example and work on it together. So here I have a double integral from 3 to 4, from -1 to 3, 4x plus 3y plus 7 dx dy. Now the x means we are going to be focusing on x and essentially treating the other one as a variable. So we're going to be starting on this outside, and then after we integrate with this, then we're going to move and integrate with our second one. So from 3 to 4, I have 2x squared plus 3xy plus 7x. So that is the integration. And then I'm going to be plugging in -1 and 3. So when I do that, I'm going to be plugging in my 3 first and then subtracting all of that and then plugging my -1 in. So I have 2 times 3 squared plus 3 times 3 plus 7 times 3 minus 2 times -1 squared plus 3 times -1 y plus 7 times -1. And then I get 12y plus 44 as my value. And now I'm going to integrate this again. So when I integrate it, I have 6y squared plus 44y. And now we're going to be plugging in our second integral over there. Oh wait, sorry, made a huge mistake. We're plugging in this outer one right there. Sorry, noticed it. So 4 and the 3. And then, like I said, brackets kind of help me just organize everything, and it's easier for me. So same thing that we did up here, plugging in the top one first, which is 4, and then subtracting it and plugging in the 3. So we have 6 times 4 squared plus 44 times 4 minus 6 times 3 squared plus 44 times 3. So after plugging that in, then I get an answer of 88 or 86. And that is how you would solve a double integral.